Okay, so me recording it in my classroom apparently did not work. So here we go with a screencast one, and we will go over this again tomorrow. Okay, so the first thing we're doing is we're solving systems with word problems. We're going to start with systems of equations, but we're going to do equations and inequalities. When we're doing this, we follow pretty much the same 4 steps. The first step is to read and identify important information. So thoroughly read the problem, pick out the important stuff, and get rid of the rest of it. Then we need to identify and define our variables. If you don't do this step, you will lose points. I have to know what your variables are standing for. We set up our system of equations or inequalities then, and we will solve it using substitution or elimination, or if it's inequalities, we will graph it. So here's our first example. It says New York City is a popular field trip destination. This year, the senior class at High School A and the senior class at High School B both planned trips there. The senior class at High School A rented and filled 3 vans and 6 buses with 285 students. High School B rented and filled 14 vans and 6 buses with 384 students. Each van and each bus carried the same number of students. Find the number of students in each van and in each bus. So the first thing I did here is I went through and I picked out the important information. Maybe we can highlight. Sorry, I've never done the highlighter part on here, so this should be fun. Nope, that's not it. That's not it either. Okay, so important information. First, I recognize that this is split into 2 high schools. We have High School A and we have High School B. High School A rented and filled 3 vans and 6 buses with 285 students. Okay, so I used that and just wrote out the information. High School B filled 14 vans, 6 buses, with a total of 384 students. So I went ahead and I wrote that out here as well. So it's pretty obvious to me that I'm going to need some variable to represent the number of students on each van and some variable to represent the number of students on each bus. So that's what I did. Once I had these, I just took this information and put it into an equation for each school. So my first equation for school A is 3v plus 6b equals 285. My equation for school B is 14v plus 6b equals 384. As I'm looking at this, I could use substitution, so I could solve for one of the variables, but I doubt it's going to come out very nice. I notice, however, that both of my b's have a 6 on them, so if I can make one of those negative, I can use elimination. So I'm going to go ahead and multiply one of my equations by -1 to eliminate that b variable. So I'm going to multiply the top one. I do that, I get -3v minus 6b equals -285. My second equation stayed the same. I add straight down and I get 11v equals 99, which means v equals 9. I take that v equals 9 and I'm going to go ahead and plug it back into either one of my original equations. I plug it into the top one and I solve and get b is 43. So my solution has to be written as a sentence. So for this problem, I would say each van held 9 students and each bus held 43. So I took information from a story, used it to write 2 equations, and then I solved those equations for my variables. Our next example is a little bit different because it doesn't give nearly as much information, but it's still enough to solve it. So it says the difference of 2 numbers is 2. Their sum is 26. What are the numbers? So this one I'm actually kind of starting at the end. I'm starting with what are the numbers? Well, I don't know. So I'm going to use x to represent the first number and y to represent the second number. Then I need to take what I know about those 2 numbers. Specifically, I know their difference is 2. Difference is subtraction, so I take my first number minus my second number equals 2. I also know that their sum is 26. Well, sum is addition, so then I take x plus y is 26. Pretty clear to me that I'm going to use elimination on this one because my y's already have opposite signs with the same value in front. So then I add straight down, I get 2x is 28, which means that x is 14. X here was just my first number, so I still have to solve for number 2. So I take that 14 and I plug it into either one of these two equations, and I solve, and it gives me y equals 12. So my solution to this one would be my two numbers are 14 and 12. Our third example, traveling with the current, a boat went 27 miles per hour. Against the same current, the same boat went 1 mile per hour. Find the speed of the boat and the speed of the current, okay? So there's two pieces of information. With the current, my boat went 27. Against the current, it went 1, which means with the current, my boat speed and my current speed were working together. So B plus C is 27. Against that same current, so the boat's going one way and the current's working against it. So it's going to be boat minus current equals 1. The way it's set up right now, elimination is easily the best way to solve this. So I add straight down, I get 2B is 28, which means B is 14 miles per hour. If you have units, you have to use them. Then I take that 14 and I plug it into either one of the original equations to get my current speed. So then I have to have a sentence. So it says the boat went 14 miles per hour and the current went 13 miles per hour. On your homework, there's probably going to be a plane one that's very similar to this. With a tailwind means that the wind and the plane are working together. Against the tailwind means the plane is working against the current. So that's going to be a subtraction problem, okay? Our next example says the perimeter of a rectangle is 16. The length is 1 less than twice the width. What are the length and the width? So your first step whenever you have a problem like this is to draw the shape that we're talking about, because it helps us to imagine it and it helps us to better solve the problem. So I go ahead and I draw a rectangle. I know a rectangle has 2 lengths and 2 widths. Then I go ahead and I write down the information it told me. So I know the perimeter is 16. So I wrote that here. I know that the length is 1 less than twice the width, which is 2W minus 1. And then what are the length and the width, which means that W is just W. Well, what do I know about the perimeter of a rectangle? Well, I know it's equal to all of my sides added together, so length plus width, and I know that's equal to 16. This is the same then as 2 of my lengths plus 2 of my widths. Now I have an equation that has L and a W left in it, but I know what L equals, right? So I'm going to use substitution to take this 2W minus 1 here. That wasn't good. And plug it in. There we go. Take this 2W minus 1 and substitute it in for the L in this perimeter equation. So I do that and I get 16 equals 2 times 2W minus 1 plus 2W. Distribute, and I get 4W minus 2 plus 2W. Combine like terms to get 6W minus 2. Add the 2 across. Divide everything by 6 to get our width is equal to 3. I take that width is equal to 3, and I'm going to plug it back into this length equation right here because it's already solved for L, which will make it so much easier to work with. So I take it and I plug it in. I get 2W minus 1 is 2 times 3 minus 1, which is 6 minus 1, which is 5. So the way I would write this as a solution is the length is 5 and the width is 3. I don't have units, so I can't put any units in my answer. So that brings us to our inequalities problems. These work almost the exact same way, but instead of an equal sign, we're going to have an inequality. So you need to pay attention to the wording that they're going to be using. So this inequality problem, and I believe on your homework it'll be the last 2 that are inequalities, but it should be labeled as such. So this example says you can work a total of no more than 10 hours each week at your job. So I'm going to go ahead and highlight this part. Maybe. No, just kidding. Purple. Okay, I guess I don't know how to highlight, which makes me very sad. No, okay. So we'll just underline it. A total of no more than 10 hours each week. If I can work no more than 10, that means that I can work less than or equal to 10 hours each week. So I know that the inequality sign for this one's going to be less than or equal to. So it says I can work no more than 10 hours at my 2 jobs. House cleaning, I get $5 an hour. At my sales job, I get $8 an hour. I need to earn at least $56 a week to pay for my bills. So if I'm talking at least, can I earn more than 56? Yes. Can I earn less than 56? No. So at least means that I'm going to be having the inequality greater than or equal to. It wants us to write a system of inequalities that shows the various number of hours you could work at each job. What this means is that it wants a graphed solution. Okay? So on this problem, I'm going to use X and Y to represent the number of hours that I can spend house cleaning a week, and Y to represent the number of hours that I can spend at my sales job each week. I know that together I can work no more than 10 hours. So I say my number of hours house cleaning plus my number of hours at my sales job has to be less than or equal to 10 because I can work no more than 10 hours, but I can work less. I know I have to earn at least $56 a week. So I have to take the amount I'm earning at each of my jobs, multiplied by the number of hours and added together, and that has to be greater than or equal to 56. So I have 5 times my number of hours house cleaning, plus 8 times my number of hours at sales, has to be greater than or equal to $56. That way I can pay all of my bills. Once I have this, it's just like what we were doing yesterday. I have to put both of these into slope-intercept form, and then I just graph them and plug in a value to figure out which way I'm shading from each line. I have a question though. Can I have a negative number of hours worked? Hopefully you answered no to that. So when I go ahead and graph this, I'm only caring about the positive x's and the positive y's. So that first quadrant on a coordinate grid, this one right here, that's the only quadrant I'm going to be graphing. Okay, only the positive x and the positive y. Next question. How do I know which axis is which job? Well, by the variables we used. X is the number of hours house cleaning. X is our x-axis. So this one goes horizontal along the bottom, so this will be number of hours spent house cleaning. Y is our vertical axis, and that's our number of hours in sales. So that's how we know where it goes. I went ahead and I got each of these equations into slope-intercept form. Excuse me, sorry. And I'm just going to go ahead and graph them. So I went ahead and I graphed this top equation right here. Oop, if I can draw a straight line, close enough, with that red line. Then I'm going to use blue to do this bottom one. Close enough. And then I just did the shading and I got the section between them. So all of my solutions for the number of hours she can work at each of her jobs to fit this criteria are in this shaded section. So this is the answer I'm looking for. Okay. Our next example says you are selling pizzas to raise money for a school field trip. Cheese pizza costs $8. And pepperoni pizza costs $9. So I have 2 different types of pizza here. Those are probably going to be what my 2 variables are. Oh no. Trying to get rid of this, sorry. You need to sell at least 2 of each kind of pizza, and you want to sell at least $180 worth. So if I want to sell at least means what? Can I sell more? Yes. Yes, I can. So when I say at least 2 of each kind of pizza, that means I can sell more or equal to. If I want to sell at least $180 worth, I can sell more or equal to. Okay, so you need to make sure you're understanding what the inequality says. So my 2 variables are going to represent the 2 different kinds of pizza I'm selling. So I'm selling a cheese pizza, that's going to be my X. And I'm selling pepperoni pizzas, that's going to be my Y. I know that I need to sell at least 2 of each kind of pizza. So for the number of cheese pizzas sold has to be greater than or equal to 2.